All right, thank you, Dr. Mueller, for the interesting talk. Our last speaker is Mr. Charles Major. Charles is the manager of GIS system at MassDOT, and he will be talking about the different projects.
Oh yeah, I'll be talking about how we use GIS and how GeoAI is advancing across transportation spaces. So we'll be talking about a variety of different AI goals, AI-based solutions for GIS problems.
Please take it away.
Yeah, thank you very much. Let's see here. All right, thank you very much. Is there a clicker here? Sorry about that. Oh, it's right behind my laptop. Thank you very much. Okay. Hello, my name is Charles Major. I'm the manager of GIS data engineering at MassDOT, as we just talked about. So I also am not coming from a civil engineering material science background, so forgive me, but I will be talking today about how AI and machine learning are changing the way that we do GIS, and they're changing the way that we collect GIS data, and et cetera, et cetera. So thank you very much for sticking around to the end. I appreciate it. We'll jump right in. Okay, so AI is everywhere now, and you've been seeing it from autonomous cars, chatbots, facial recognition, computer vision, all sorts of things. So what are we talking about? And we've seen some other models that have sort of explained it, so I will hopefully not have to spend too much time here. But the way that the way I like to visualize it is using artificial intelligence is a very broad term now, simulation of human intelligence and machines. And the machine learning within that, specifically an application of AI that allows machines to learn without being specifically programmed and to make decisions based on training data. When we get to sort of go in a bit, we get into sort of deep learning or machine learning based on these artificial neural networks that were discussed in some of the previous conversations. And they can help solve more complex issues and more complex problems, albeit sometimes they solve those problems in a little bit of a black box, as we've also discussed. Sort of within that, we have generative AI, which includes things like large language models such as ChatGPT, but are not exclusive to that. And then sort of on these sides, we have natural language processing, which is the ability to interface with these models using language instead of direct inputs, and computer vision, which is processing of information by these computers. Within the context of GIS, which is sort of where my group is very focused, we kind of consider the whole umbrella GeoAI. And so we're going to talk about a variety of these different tools and how we do stuff with them. So with that, I'll kind of go into, is it this one? Yeah, go into some examples. So, there's a ton of examples, but I think some ones that we can focus on and what's really been emergent and helpful for DOTs are things in safety analytics. In particular, my group is very interested in asset extraction and change detection. So we manage the Massachusetts road inventory and do all of the federal reporting around GIS roadway assets. So we're very interested in that. Crowd detection is useful and has been used more and more for different types of events. Disaster recovery management is becoming an incredibly important focus in the light of some of the more recent things, but also just in general. And then very much interested in the traffic intersection and car counts, as well as graffiti and lane cover conditions. We'll touch base on a lot of these. So AI has got a lot of words. There's a lot of things here. And I think what's really important is to think about that when we're trying to approach a variety of problems, a lot of these work together, and it is important to parse them out, but really they're all kind of within the context of, hey, what are the different tools in our toolbox that we can use to solve GIS problems using artificial intelligence and machine learning? So what are the types of patterns that we look at? Object detection, that goes back to things like classification. We want to know where things are and if they're where they're supposed to be. And in some cases, we can start to look at condition prediction. So we're looking at events and phenomenons and how those can change as a result of other factors, and then pattern detection. So, emergent hotspots for 911 calls, other sort of heat maps and stuff like that. So we happen to be an ArcGIS shop at MassDOT, but we are fortunate in that we're able to sort of use deep learning, prediction, classification, all these things kind of can work together. And so even including natural language processing. So we're very excited. And the reason that it all works together inside our enterprise platform and why that makes us excited is this idea of the system of systems. And so especially from like a business and governance side, the ability for all of these different data sources, all of these different tools to be available and to be able to be dispersed via our enterprise system allows us to more rapidly and accurately generate information, which then drives engagement because especially when it's things like real-time data, we're able to get stuff out there quickly, accurately, include a variety of data sources and help decision makers on the fly. We found that the expediency and the completeness and the fact that we're able to provide new data that we were not able to provide before is really great because it not only drives engagement, but it turns some of our consumers into producers. They want to come back and say, hey, wow, you got this to me. I was able to make this. Can this be implemented somewhere else? And so we have this positive feedback loop within our stakeholders that allows us to get more done. So let me give you an example of what that might look like even within the MassDOT. So let's talk about bridges for a second, because I think we have a lot of bridges, a lot of bridges here, which is great. More bridges than I'm used to. So we can use machine learning based classification to extract text from signs. So we have a vehicle that runs and collects pavement data, but can also collect our sign locations, the XY points. We can use LiDAR on that machine to collect the actual information from those signs. So we're already running pavement. We can then go and grab the signs, get that sign point with the location. We can get the bridge height, right? So that's useful. But is it useful independently? Sure. But we can harvest that bridge height. We can get it amongst all the bridges on the state. We can understand how our bridge heights reflect our truck routability in the state, right? So we can get this information. We can provide a routing tool, get it over to our freight people, and they're able to be like, wow, we have better access to routing freight in the state, right? And this is all coming from that other pavement group. Analytics can be done then once we start to understand how that routing for each of those routes starts to add up. They can give us that routing data back, and we can understand where are the high volume truck corridors. That might go back into planning, as well as reduce bridge strikes because we have more accurate height data, but it can go back into planning and it can help us understand and better plan for freight and the changes to freight fluctuations and volumes in the future. So this is just one small example. We see this everywhere. And just again, we like to disseminate data via our GIS open data portal, but it's really just faster, more accurately, and it gets delivered to decision makers, speed, right? And we can get the downstream analytics much quicker. We can get them data back from the stakeholders involved and the users of that information much more quickly. And it's reinforcing and reinforcing, reinforcing. And what we're starting to see is this technology in and of itself is helping us tear down some of the silos that have been happening operationally within the MassDOT. So we're very excited about it. And it's just this cascading event. And one thing at least we're focused on, I know there's some concerns around AI here. I think if we think about it as a tool set, we are re-looking at the way we do GIS. We're not using this technology to cut jobs. Our jobs are changing and they're becoming different, but they're not going away. So yeah, I think once again, we're gonna go through some quick examples from different DOTs, and we're gonna go over some things like asset extraction, predictive analytics, real-time video, and traffic management, and some others. So we kind of already went through this. There is this fourth one, and this is something that's on the horizon. There are some GIS-based large language models using natural language processing coming down the line. They're not here yet, but we're very excited for when they get here because I think it'll make GIS more accessible to a lot of people. Oh, thank you. I forgot to buy. Appreciate you. All right. So let's jump into some of these use cases, right? So as we know, DOTs capture street level imagery every 2 or 3 years. This is for federal reporting. A next step that we're looking at building out, and others are building oriented imagery networks that allow users to zoom around, and then they can catalog and classify each asset. So how can we make this more efficient? So we can train a deep learning model to detect different types of road cracks from that oriented imagery. So let's explore these road cracks and pavement condition. So again, showing you a similar approach to how one would prep and train a deep learning model to assess damage types. We can see using video and computer vision, a model is trained to detect road cracks on the fly. And that's just one example. So another one we have is car detection and using drone imagery and deep learning. So we can get car counts, we can understand as well parking lot counts, right? Oh, I'm way behind. Oh my God, I'm so sorry. Sorry, this was the real-time detection of cracks. My apologies. And now we're on to the car detection from drone images using deep learning. So we can use aerial imagery and deep learning to assess car counts. We can assess parking lot counts, and we can sort of collect assets and collect that information for all the different assets. This is actually something we're doing at the DOT right now. And this kind of is involved with some of the video AI technology. So we're able to get information here, right, with computer vision around intersections. So for example, we can understand not only accidents, which have been historically recorded through police reports, et cetera, we can understand near accidents. So there's a much better handling using these intelligent transportation systems that involve things like computer vision and AI. So this is a little bit more in depth, an example of what, right? We can take this live data even and directly send it to a dashboard in GIS. And this is gonna just provide our operations people the ability to respond to a variety of different circumstances effectively and quickly. All right, so next up, we've got AI for disaster response. So this is another emerging use case in a lot of DOTs to respond to disaster events. And so we're going to show you how AI techniques can be applied to expedite disaster response. Let's see here. It's just lagging. Okay. So the first step, right, is we can detect damaged structures. So AI models can run on aerial imagery and output feature classes based on damaged structures, as opposed to, and so we can better understand what percentage within an area, what percentage of buildings may have been damaged. We can understand how badly they've been damaged. We can do the same thing for roads, and we can even do on the fly rerouting based on the knowledge of which roads have been damaged. Again, this all kind of comes back together because our end products in the GIS group is to be a service and provide information to our different operational groups. The operational dashboard is sort of one of the outputs. So what does that look like? All right, so here we have some imagery taken after a disaster. What could we do? We can use machine learning to, let's see what will pop up. There we go. To set some threshold, train a model that maybe it's been trained, and to assess where the damaged buildings are. And this can be really, really helpful in understanding where we need to send emergency services or which areas have been more damaged than others to help track sort of the total damage. Additionally, we can do the same thing with our roads. And so this is interesting because this is sort of feeds into the idea of, okay, well, after an accident, our roads have been damaged. How do we route so people can either get to safety or we can get emergency services where they need to go? And so this kind of all falls back into this data then can be quickly consolidated and moved into a GIS-based dashboard, which then goes back to our operations group. So this has been like a game changer for a lot of different DOTs as they start to sort of build these up. And so it's sort of one that's pretty cool. So another one is using generative AI with post-disaster imagery. This is a new tool coming out that we're excited about, but haven't quite had access to. But in the sake of time, I'll probably not go super deep here. But the idea being that we can use NLP and sort of prompt it without necessarily having to do a lot of training on models directly. Again, the purpose here is to give access to this kind of tool to people who maybe don't have a traditional machine learning background. And so, yeah, so once you start to do that, you can build these models essentially without having to actually have as much familiarity with the science. So what about some stuff that we've already accomplished here at MassDOT that we're excited about with our partners? One of them is we've been able for the first time to get a complete collection of all of the crosswalks in the state. This has been really useful for doing pedestrian routing. It's been very useful for our planning agencies and our multimodal our planning groups and our multimodal groups, and those trying to help further multimodal movement in Boston and Massachusetts as a whole. I think a development in this model is that we're kind of working to score them based on degradation, because we know that a clean and fresh crosswalk can be more protective if it is clear where it begins and ends. So yeah, so this research project was accomplished in 2023, and we're sort of rebuilding and working forward, moving forward on sort of the quality assessment now. Another one is I'm going to show you some information from the Massachusetts road inventory. This is the sidewalk. So you may imagine that trying to understand exactly where every sidewalk is in a state like Mass. Oh, I'm out. Okay. Okay, I'll finish up. Yeah, I'm almost done. Sorry. So we need to understand where all the sidewalks are in Massachusetts. So we've historically had to have interns and co-ops go through with aerial imagery and do that by hand. And it is laborious, it is slow. It takes a year and a half to go through the whole state. Using machine learning and LiDAR for, depending on jurisdiction, we've been able to get LiDAR and or using some aerial imagery and machine learning. We have been able to speed that up. So it historically took about $353,000 to go through the entire state if we look at staffing costs. If we were to use machine learning, we are now doing that in, we can do the whole state in about 3 months. So the costs are significantly less. So we're very, very excited. These are still in development, and we're working on how to do quality assessment and then bring in the American with Disability Act to understand exactly where and where not the ADA compliance is, so we can prioritize cleaning those up. But these are just a variety of cases of where we're bringing in ML and AI in transportation and GIS, and we're very excited to keep moving forward with that. So thank you.